Alright, if you were absent on Monday, okay, on Monday we're going to be talking about multiplying polynomials. This actually might be a lie because we all might be at the play, in which case we'll do it Tuesday, but it's better to be prepared. Alright, depending on the elementary school you went through, some people learned how to multiply using the box method, right? Where 342 you would break out up to the hundreds, the tens, and the twos. 23, break it down to the tens and the ones. Right? If we're talking about what she is doing, right, she's multiplying each part of the factor. That should say part of the factor. I'm just really sleepy. I'm sorry. Each part of the factor in its own space. Alright, so for example, I might not know what 342 times 23 is, but if I break it down, I know what 300 times 20 is 6,000. I know that 40 times 20 is 800, and I'm breaking it down into smaller numbers so then I can get a final answer. Now at the end, what she should do is take these and add them to get her final answer. Now, we don't have to do all that today because, again, we're talking about polynomials. As a reminder, a polynomial is just a math sentence with more than one term. Alright, and on Friday, more than one term. On Friday, we talked about adding and subtracting polynomials and how you can't combine like terms. When we're multiplying polynomials, all we're going to focus on is the distributive property. Alright, but when we talk about the distributive property, we're going to distribute, but we're going to distribute all the terms. Alright, to every term in the second parentheses. Alright, so for example, if I have 3 terms right here, I have 1, 2, 3, I'm going to multiply each one times everything in that second parentheses. So watch, I'm going to start with 3x squared times 2x. If you forgot the exponents, okay, so that exponent rule, if you're multiplying exponents, you're going to keep the base and add the exponent. Alright, so for example, 3x squared times 2x to the first. 3 times 2 is 6. X squared times x to the first. I'm going to keep the x. And 2 plus 1 would be x to the third. Alright, 3x squared times 3 is just 9x squared. Alright, and I'm done for the first term. I can check it off. Alright, now I have to distribute the second term. 4x times 2x, that's like 4x to the first, so 4 times 2 is 8. X to the first times x to the first, I'm going to keep the base and add the exponents, that's x squared. And 4x times 3 is just 12x. Alright, lastly, so done, distribute that. Okay, lastly, I'm going to distribute the 2. 2 times 2x is just 4x. Okay, that should have a plus sign, it's just ugly. Plus 4x. Alright, and 2 times 3 is 6. If you love the distributive property, you're going to have a really fun time doing this because we're just distributing all day long today. Alright, lastly, I'm going to put it in standard form. So my biggest exponent is going to go first. I have 6x to the third, nothing to combine it with. 9x squared plus 8x squared is 17x squared. 12x plus 4x is 16x plus 6. Okay? For C, same deal. Alright, I'm going to distribute 2x squared times x squared. 2 times 1 is just 2. X squared times x squared is x to the fourth. 2x squared times x is 2x to the third, because remember this is like x to the first, so when I add the exponents it's 2 plus 1. And lastly, 2x squared plus 1 is 2x squared. Alright, done with that first term. 10x times x squared, 10x to the third. 10x times, oh, almost forgot one. 10x times x is 10x squared. 10x times 1 is 10x. Sometimes it's going to be long, so like if scratch paper helps you to stay organized, maybe just do it. That's a check mark on that one. 1 times x squared is just x squared. 1 times x is just x. And 1 times 1 is just 1. Alright, this is what? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 terms. And you might think, Mr. Zara, that's too many terms. You're correct. We're going to have even more terms, but it just is what it is. Alright, I'm going to put this in standard form. So 2x to the fourth first. Okay, I have 2x to the third plus 10x to the third. That's 12x to the thirds. 2x squared plus 10x squared. Ooh, plus x squared. Almost forgot that one. That's 13x to the thirds. Nope. 13x squareds. Alright, I have 10x plus x. That's 11x. And then the 1 at the end. That's a big number, or a big polynomial, but it is what it is. Alright, one more example. Here we go. X times x to the third is x to the fourth. X times 6x squared is 6x to the third. X times negative 5 is minus 5x. Just be careful. If the term is minus 1 right here, you have to distribute it as it's a negative 1. So like negative 1 times x to the third would be minus x to the third. Negative 1 times 6x squared would be minus 6x squared. Negative 1 times negative 5 would be plus 5. Okay, so be careful because you have to distribute the negative with a number. Alright, so combining like terms, I have x to the fourth, 6x to the third minus x to the third is 5x to the third. Alright, minus 6x squared minus 5x plus 5. Done. Alright, it keeps going. And you might think, Mr. Zara, this is taking up my time. Yes, I know, but it is what it is. It's one of those skills where like it's easy and repetitive, but it will lead to your success when we do quadratic equations. 3x squared times x to the fourth is 3x to the sixth. 3x squared minus 2x is negative 6x to the third. 3x squared times 1 is positive 3x squared. X times x to the fourth is x to the fifth. X times negative 2x is negative 2x squared. X times 1 is x. Negative 1 times x to the fourth is negative x to the fourth. Negative 1 times negative 2x is plus 2x. Negative 1 times positive 1 is negative 1. Alright, so combining like terms in standard form, I have 3x to the 6 is my highest. Right? If it helps you, you can kind of like scribble it out once you use it. I have positive x to the fifth, that's the only one, so plus x to the fifth. Done. I have minus x to the fourth. Okay, done. I have minus 6. Oh, that's a 4. It's just really ugly. Sorry. It's not getting better. Sorry. Minus 6x to the third. Done. Alright, I have positive 3x squared minus 2x squared. That's just 1x squared. Done with both of those. X plus 2x is 3x. Done with those. Minus 1. So many terms. Okay, but it is what it is. That's okay. Alright, now, the opposite of doing this, right? When we are doing the distributive property, sometimes they're going to give you an expression and they're going to ask you to factor it. Alright, to factor something is the opposite of distributive property. That's not really true. Do I want to say that? This is one of those 4 AM problems, so sorry. The factor is the opposite of distributive property. For our purposes right now, for factoring, it's going to be the opposite of distributive property. There are other ways to factor. We're going to talk about those later, though, not right now. Okay, but right now we're doing the opposite of distributive property. So, like, when you're doing this, you have to think. Alright, and you're going to think about what can, oh my god, I factor out. Alright, what do I have in common? So here, right, I have 6 and 14. I can divide both of those really just by 2, right? So if I pull out a 2, that's fine. And they have an a and an a squared. So at most, I can take out 1a from both of those terms. What goes in the parentheses then is what happens if you divided it like 6a divided by 2a. Okay? So if I did 6a divided by 2a, that would just be 3. If I did 14a squared divided by 2a, alright, 14 divided by 2 is 7. And now you need to know one more exponent rule. Okay. All right, for dividing exponents. All right, you're going to keep the base, subtract the exponents. That should say subtract. Subtract the exponents. All right, so for example, a squared divided by a, I'm going to keep the base, a. I'm going to subtract the exponents. 2 minus 1 is just 1, so 7a. You can always check to see if you're correct by doing the distributive property. 2a times 3 is 6a, right? 2a times 7a would be 14a squared, so I know I'm correct. Alright, same here. I have 2x to the 4th plus 2x to the 5th plus 2x to the 10th. I know I can definitely take a 2. Alright, and the maximum number of x's I could take out of all of these is x to the 4th. Okay, because my lowest term right here has x to the 4th. I can't take out more because then I would run out on this side. Alright, if I take out 2x to the 4th and I divide 2x to the 4th by 2x to the 4th, that's just 1. 2x to the 5th divided by x to the 4th. Remember, I have x to the 5th divided by x to the 4th. I'm going to keep my base, subtract the exponents, that's x to the 1st. So plus x to the 5th. Nope. Plus x to the 1st. Ooh, sleepy. Alright, and then 2x to the 10th divided by 2x to the 4th. X to the 10th divided by x to the 4th. 10 minus 4 would be x to the 6th. Okay? And again, you can check you're correct by distributing. 2x to the 4th times 1 is 2x to the 4th. 2x to the 4th times x is 2x to the 5th. 2x to the 4th times x plus 6, x to the 6th is 2x to the 10th. I'm correct. Alright, so we're going to practice like this. I know I can take out a z because there's one z. 6 and 15 have 3 in common, so I could take out a 3. That leaves me with 2z minus 5. I'm going to check it. 3 times 2 is 6. Z times z is z squared. Minus 3z times 5 is 15z. Correct. Alright, sometimes it gets a little wild with bigger numbers. You might have to guess a couple times. I'm going to guess that I can take out a 7. Okay, I only have one w here, so I can only take out one w right there. 42 divided by 7 is 6. W to the 3rd divided by w is just, that's like w to the 1st, so that's w squared. Alright, minus 14 divided by 7 is 2. W divided by w is just 1, so I don't need a w. Plus 77 divided by 7 is 11. W fifth divided by w. W to the 5th divided by w to the 1st. That's w to the 4th. Alright, and I'm done. Oh, I forgot to box this one final answer up there. Okay, I can check. That's 42 w to the 3rd minus 14 w plus 77 w to the 5th. Done. Correct. Alright, now every once in a while you have something weird like this where you have some terms on the outside. In this case, the common term is, well, we have 2, right? I could pull out a z squared, because this has 2 z's and this has 3 z's, so the most I could pull out is 2. But I could also, I guess this is common terms r. Alright, I could also pull out the whole parentheses a plus b. Okay, so if I take out a z, let me scroll up. Take out a z squared times a plus b. Alright, and times that whole thing, alright, as parentheses, that would be 1 right here, plus z. I know I'm correct because I have z squared a plus b, so that times 1 is just z squared a plus b, and z squared a plus b times z would be z to the 3rd a plus b. Now you might ask, like, shouldn't I distribute the z first? I mean, you could, but it wouldn't really change the fact that we are multiplying by both z squared and the a plus b. Alright, lastly, sometimes they're going to hit you in the face with a fraction. Don't freak out about it. Take out a half. Alright, 3/2 divided by 1/2. If you forgot, 3/2 divided by 1/2. Key change flip, that's 3/2 times 2, which is just 3. Okay, so that's 3s squared plus 1. Alright, now I know I told you never distribute a fraction, so like this is a bad example, but if you had to check it, half times 3 is 3/2 s squared, half times 1 is 1/2. And I'm sad because I distributed a fraction, but it's okay. Alright, now this is where it gets weird. Dang, it's so weird. Alright, just go with the most simple stuff. At the very worst case, you don't pull out enough terms. But like at least try something. So for example, I'm going to pull out a 3 because all of these have a factor of 3. That square root of 2 is just in there. I'm not going to touch it. Let me look at p's. I have p to the third, p squared. So I'm going to take out p squared because that's my lowest term for that variable. My lowest term for r is r squared. Okay, so taking that out, 15 divided by 3 would leave me 5. P to the third, p divided by p squared would be p to the 1. R to the fourth divided by r squared would be r squared. Minus 6 divided by 3 is 2. P squared would cancel out, and I'd have r to the third. Plus 9 divided by 3 is 3. P squared, r squared divided by r squared would cancel out. Okay, plus 3 divided by 3 is 1. I'm not going to write it. I have that weird square root of 2. P to the third divided by p squared is p to the 1. R to the 6th divided by r2 is r to the 4th. Alright, ugly. I know, but it's okay. Alright, lastly, 0.4x to the 9th divided by, or minus 40x to the 8th. Okay, I'm going to take out a 4x to the 8th and say that 0.1x minus 10. Maybe. If you would do it differently and you got something else, that's fine. This should be correct too. Just double check. If it works with distributive property, you're good to go. Alright, if you need more practice, it's going to be right here. Again, this should be, now sometimes you have to do distributive property and then subtract. You're going to subtract last. Alright, so don't do anything until you do distributive property. So that should be 4x to the third plus 4x to the fourth plus 3x squared plus 3x to the third, right? It's going to be this whole thing minus, now we do the second parentheses. So 2x to the third plus 2x to the fourth plus 2x squared plus 2x to the third. Alright, now I can distribute my negative or my minus sign to everything inside. Again, if you can do it in your head, cool, but this is where like being organized will help, because like a lot of people will miss that minus sign and they'll just go straight to combining like terms instead of distributing it. So I'm going to rewrite it. And you're saying, Miss Rosario, we're writing so much, I don't want to. Well, too bad. Alright, 4x to the third plus 4x to the fourth plus 3x squared plus 3x to the third minus 2x to the third plus, nope, see, even I messed up. Minus 2x to the fourth minus 2x squared minus 2x to the third. Alright, my highest variable is x to the fourth. So I have 4x to the fourth minus 2x to the fourth. That's 2x to the fourth. Okay, cross them out because I use them. I have 4x to the third plus 3x to the third. That's 7. Minus 2x to the third. That's 5. Minus 2x to the third. That's 3x to the third. Alright, I have 3x squared minus 2x squared, that's just plus x squared. Alright, here we go. Last one. Same thing, I'm going to do the first set first and then the second set and subtract the last. So I have we're talking about z now, z squared minus 4z plus 5z minus 10. Alright, that's the whole first term when you multiply. Minus sign, second term. 13z squared minus 39z z minus 26z. Oh, not done. Oh gosh, 26 times 3. Too early for this. 78 plus 78. Alright, again, I'm going to distribute that minus sign to everything. So I have 2z squared minus 4. I'm going to combine like terms while we do that. So that minus 4z plus 5z is just plus 1z. Okay, minus 10. Let's see if there's any like terms. Okay, we're just going to go for it. Minus 13z squared plus 39z plus 26z minus 78. Alright, so to combine like terms, I have 2z squared minus 13z squared. That's negative 11z squared. Z plus 39z, that's 40z plus 26z. That's what, 66z. Negative 10 and negative 78 is negative. Oh, let me make that better. Negative 66z. Negative 10 and negative 78. Oh, God. Negative 88. Okay. I'm not gonna lie, I'm pretty tired, so skip exercise 4. Alright. Now, find a polynomial that multiplied by 2x squared plus 3x plus 1 gives 2x to the third plus x squared minus 2x minus 1. There are many things you could write for this. So, I want you to try it. Alright, I'm going to check it when I read it. Alright, and again, this is a whole problem set. Alright, there's what? All the way to b, w, x, y, z. So that's 22. There's 22. I want you to pick 11. Okay, and I will check. I will check. Alright, now the only thing that's weird, I want you to, let's see, how many of these? 3, 6, 9, 10. I want you to pick 5 of these, but not A, so we're going to talk about A together real fast. Alright, so A is A plus B squared. We hinted at this in the last video, but in case you didn't know, you can't just distribute the squared. This means A plus B times A plus B. So if I do that, I'm going to distribute the term both times. A times A is A squared. A times B is AB. B times A is AB or BA. Either way, it's the same thing. B times B is B squared. Okay, so I have A squared plus 2AB plus B squared. Alright, so not including A, pick 5 of those. Alright, and same thing, this has 7. You're lucky because I'm feeling sleepy, so you only have to do 3 of these. Alright, I don't know why I included this last page. Beatrice writes down every expression in the problem one after another, linking them with plus signs because she is crazy. Why would you do that? Alright, but she's left with one very large expression. Is that going to be a polynomial? Is it equivalent to a polynomial? Yes. If she wrote minus signs, would it still be a polynomial? Yes. If she wrote multiply, would it still be polynomial? Yes. Remember, all a polynomial is, alright, is a math sentence with more than one term. Even if she combined every single thing in here, we have different variables, we have different degrees of variables. Like, there's no way that it would combine down to just one number. I think. I mean, maybe it would, but I'm not about to sit here and try it, and neither should you. Go to bed. But otherwise, that's it. Again, we're going to save this video for if we do teach on Monday. If we don't, this is what we'll be doing on Monday.